Everybody, how are you all? I hope you all are fine and safe and doing good in your life. Okay, so I'm Aman Gupta, a 12th grader student from India, and so today I've worked upon Riemann Zeta function, and I have just tried to evaluate zeta of 3. Okay, I've written the solution, and I'm just gonna explain you, right? So before that, let me just tell you what's zeta function. Well, what's Riemann zeta function, right? So there was a great mathematician Riemann, and who discovered a very weird looking, what do you call it, summation, what do you call series? Okay, so zeta. Oh, wait a second. I Yeah, zeta of s is represented as the series from n equals 1 to infinity of 1 over n to the s. So this was the series. Well, this looks easy, but when you just evaluate for s, and when you put s as um, like integers, and when you just try to put when you just put s equals 1, the series would diverge, and when you put s equals 2, and we have Basel problem, like that is, well, look, we have when it's zeta of 1 is divergent, right? It's to infinity, so we don't care about that. But zeta of 2 is Basel problem, like known as Basel problem, and it evaluates to pi squared over 6. Okay, so we are not going to talk about this in this video, but we'll try to talk this on later. Okay, so let's just come up with our solution, right? So for you guys, I have the solution. Let me just put that object in front of you. I have wait a second, let me just do it slowly and slowly and slowly. Otherwise, I would have changed, like I would have a new page. I don't know what's the function of this software. So yeah, so we have, just look closely, guys. Okay, we have Fourier series, like I've written it. This is my handwritten. I was just writing it before the video, like this video. Okay. So we have that Fourier series is represented like that. Okay, so f of x is just a naught over 2 plus the series from n equals 1 to infinity of a n cosine n x, right? And plus the series again from n equals 1 to infinity b n sine of nx. So then what you would ask, that what is a naught and a n and what is b n? So just beneath of this represented this big thing, we have written, like I have written, that a naught is just the integral of like 1 over pi, and the integral of f of x, which is this function. Okay, so you would have f of x like x cube, x4. You can have any kind of function, 2x plus 5, yeah, any kind of function. Sorry guys, I'm just suffering from cough. Anyways, so we have a n as 1 over pi, the integral, and bounds will be like, I'll just tell you where would be the bounds, like how would I decide the bounds? Okay, so a n equals 1 over pi, the integral of f of x times cosine of nx. So you can relate it, like when you evaluate a n. Should I change the color? Yeah. So when you evaluate a n, we would consider in this integral as the right side of this a n. Okay, like the cosine of nx. So you can relate with that. And for bn, it's the same thing. When you evaluate, oh wait a second, what's it's like that, and we have this thing, right? So it's easy, it's quite easy to evaluate these things. Well, I'm just suffering from cough. It's quite serious, so my voice would be slightly deeper side, like. Anyways, let's move on to our problem. So we have for fx equals x cube. Like I was just uh, trying to evaluate the zeta of 3, right? So, well, I got the result in a form where it's divergent, and when you evaluate when zeta is zeta of 3, it's divergent, but I just did it through Fourier series method, okay? And this method, I saw this method from Michael Penn. It's a very good mathematics teacher, and he's very good. So you should just check out his channel also, right? So before that, you should just check out my video. So x cube, like I'm just representing x f of x as x cube, and everything would be same as you can see, because there is no x would be if there is no x on the right hand side would be changed as f of x would change. So for evaluating a naught, like we know the formula for a naught, right? I've written over there. It's just 1 over pi, the integral from negative pi to pi. Okay, let me just tell you. So here I should mention that x belongs to negative pi to pi for sake. Yeah, right? Okay. So when you just look at it, it's an odd function, and when you evaluate from negative a to a of an odd function is just 0. So successfully we have got a naught as 0, right? And the same thing when you just look at an, look, x cubed is an odd function and cosine of an x is just an even function. So uh, look, when like odd times even is so yeah, you can also check, or you can also solve this integral by yourself, and you would get the answer as 0. And I just thought when I was just exploring this integral that this is an odd function and this is an even function, so it's definitely gonna be 0. But when we talk about bn, right? So there is bn I've written. When you just look at it, this is an odd function. This is also an odd function. So odd times odd is just like positive, you know. So we don't need to worry about that, and we are going to evaluate this integral. So like steps are like written over here, and I think I should explain it to you. Well, I'm not in the condition to talk. I'm not in the condition to speak, but I'm just trying to speak as much as I can. Anyways, uh, okay, so like both are odd functions, so we can just multiply with 2, and we can evaluate this integral from 0 to pi. We can do that. And from B, I hope you know this YouTube channel. This is very famous. BPRP, Black Pen, Red Pen. So this channel has like the man, like the owner of this channel had developed a formula for biparts, a new way for biparts. So this is known as DI method. Okay, so it's very easy and it's very comfortable for biparts. So just derivative of the function and the integral of the another function, and just alternatively multiplying both the things, adding up to, and the last thing of both the derivative and integral would be multiplied in an integral. And let me just tell you how it's gonna work. Here I did that. So when you just look at it, like plus x cubed times minus 1 upon x times cosine of an x. So I've just written over there. I hope you can see that. Similarly, it's going to multiply with these two things. So Well, it's positive, but it's gonna be zero just because sine of nx when when x is pi or x is zero, no matter sine of n of zero or n pi is just zero. Okay, always. We are talking about n is natural number, so we don't need to worry about anything. It's gonna be zero, but not cosine nx, right? So for this thing, this thing gonna be happen, and they are going to be evaluated from 0 to pi. And the last thing of the both integrals and derivatives would be in an integral, and like it's quite easy to evaluate it. It's just sine of nx, right? And well, when you evaluate sine of nx from 0 to pi, it's just 0. So this integral is also going to be 0. So we are going to be left with this thing and this thing when we are evaluating from 0 to pi, right? Well, so we have like look, I let that this integral is I1, so don't forget about that. I cannot save it in a PDF, otherwise I'm not gonna make this video. If I could save this in a PDF, then I won't gonna teach you, but I have to record it in a manner that I would be able to see that in later. So yeah, we have left with this thing and evaluated from 0 to pi, and this thing is gonna be 0 just because sine of an x. I told you the reason between this, right? Reason of this. So we have I1, just I have put the values pi and then subtract the 0. So you will be end up with this expression. Look, cosine of nx is just negative 1 to the n. You need to know about this. Just because when n is even, you would get 1, and when n is odd, you would get negative 1. So, so this thing gonna be happen. Okay, so you need to know about this, and this is very important. So just replace the cos and con x cos n pi with negative 1 to the n, and just doing all the stuffs. And finally, we have bn as 2 over pi times I1. So I1 over here we have. So just putting these things in here, and we would have bn as 12 times negative 1 to the n over pi n cube minus 2 pi squared times negative 1 to the n over n minus 12 over pi n cubed plus oh well, I did a mistake over here. We don't have pi. We would just n. Just because one pi is just cancelled out with the pi what it was in the numerator. Okay, so we have bn, right? And well, what the heck, I don't understand the shit, man. Like I'm just sliding this left side and just it's gonna be like disappeared. What the fuck is this? I just hate them. I just hate about this. So hey guys, just solve the problem. Like to solve the problem of this Microsoft whiteboard. I don't know what the fuck is this. But anyways, let's not to be angry. So we have x cubed, the function, as the summation of this thing and sine of nx, right? So we want to just disappear sine of nx. So for that sake, I just have to make sine of nx as 1. And when x is 0, so sorry, when x is look guys, I did something wrong, I think. Wait a second guys, let me just fix it, okay? Oh yeah guys, I again did a mistake, and let me just correct it, right? Actually, it's not gonna be 0, it's gonna x as pi over 2, and pi over 2 is just 1, right? So wherever I just wrote 0, I'm just gonna replace it with pi over 2, and pi over 2, and we have again here as pi over 2. Again we have as pi over 2, all, right? So, and just evaluating the zeta of 3 after just this final steps we are just going through. So well, and before that, let me just erase all these stuff just because there are mistake in this. So we are going to evaluate zeta of 3, right? So zeta of 3 is here. So I'm just gonna write 2 pi squared ln 2. I'm just gonna explain you the last steps. No, don't worry. 2 pi zeta of 1 minus pi over 2 is just 21 over pi zeta of 3, right? Wait a second, damn it. I hate this app. I'm not gonna record this. I'm not gonna record any video on again on this app. Zeta of 3, right? So we can evaluate that zeta of 3 is just pi over 21 of this whole thing. That is 2 pi squared ln of 2 plus 2 pi zeta of 1 minus pi over 2. So this is the result. Well, as you know that zeta of 1 is divergent, so zeta of 3 is also divergent, but I just made a close form of that thing, right? So well, remember that we had x cube as this thing, so we just have to make sine of nx as 1. So for that sake, I have to just put x equals pi over 2. So we did. So we have pi over 2 whole cubed. Oh man, again I did mistake, man. I don't know what the fuck I'm. Sorry for the mistakes, guys. After just correcting all my mistakes I did, we have finally the result. So just cubing pi over 2, we would have look, wait a second. Yeah, we would have this series as pi cube over 8, right? So just breaking the series as we can do that and just putting constant outside the series, we would have this thing. Look, negative 1 to the n over n cube is just negative 3 over 4 zeta of 3. Look, I'm not gonna evaluate this thing in this video, but later on I will try to do this, right? And when you just look at this thing, this series, we would have the series from n equals 1 to infinity of negative 1 to the n over n. And this is just negative ln 2. You can just check it out when you just put ln x or ln1 plus x as the series, right? And we have this thing as zeta of 3, we can see that, and this thing as zeta of 1. So just all these stuffs are gonna pi cubed over 8 equal to pi cubed over 8, right? So just solving these things for evaluating zeta of 3, like you can see that over here. We can just you can just check it out, yeah, it's not a big deal. Just cancel out all these stuffs and you would have negative 9 over pi zeta of 3 and negative 12 over pi zeta of 3. These two are gonna add it up and to give 21 over pi zeta of 3, right? And we would have 2 pi squared over ln 2, and we have 2 pi zeta of 1. So and now just calculated zeta of 3 as pi over 21 times the whole thing as like pi over 21 times 2 pi squared ln 2 plus 2 pi zeta of 1 minus pi cubed over 8. So finally we did it. And but if I'm gonna just look at this, that how much I worked. Look, I'm the okay. So yeah, this is the thing we are just dealing with, right? So for today, it's enough, I think, guys, and thank you for watching this video. We have completed 20 minutes, and well, I have been writing it in about 40 minutes. Yeah. So thank you for today, guys, and I hope it's correct. Well, I'm gonna check it out just because I just completed the writing of these things and just they just begin the video. So, well, if you find any kind of mistakes, then just tell me in the comment section. Thank you so much, guys. Thank you. I love you, both.